Welcome. In this video, you will see the Spanish consortium contributions in the Optimum project, validated via a dual physical logical demonstrator, precisely, a secure smart factory scenario where a robotic arm supports the assembly and welding of hybrid batteries. Compared to Industry 4.0, traditional processes, in most cases, fail to obtain the highest return on assets, data, and resources that are available within the factory. For this reason, Optimum seeks to create platforms that will allow achieving this connectivity throughout all the available entities, especially trying to integrate information systems with physical control systems, increasing efficiency, security, and the level of production in the industrial environment. In the Spanish consortium, we wanted to automate a pilot plant to enhance the hybrid batteries assembly process and its related diagrams by following the Optimum approach. As the main objectives for the case, the first consists of defining and architecting a set of distributed and modular control and assistance functions, to be embedded in the industrial systems. The second main objective consists of interconnecting and orchestrating securely and efficiently the different elements in the smart factory scenario. The automation of the pilot plant results from the research, development, and integration of novel industrial techniques and technologies. The physical demonstrator consists of an automated plant for effective human-machine collaboration in the hybrid battery assembly process. The Optimum architecture provides real-time control over the carried-out process, enhancing the different tasks, and allowing the monitoring of the various participating elements. In the video, you can see how the robotic arm places a battery in the mounting blister and then checks the battery polarity and voltage. Depending on the battery status, it will proceed as appropriate. After that, the assembly validation will be carried by an artificial vision system. The human operator will also place the top matrix, set screws, and some nickel to execute welding. In the video, you can see how the robotic arm performs different welding points in a battery set by using a supercapacitor. Later, the welding points are verified by an artificial vision system. In the meantime, the whole process is broadcasted through a projector. After this process, the human operator places the connectors in the battery cover, while a new assembly process is carried out. Regarding the logical part, two main components have been implemented. First of all, creating a secure smart factory to secure and defend through cybersecurity all the productive processes of the smart factory, since a large amount of data is generated and all of it is of great value. Allow the protection of plants and assembly lines through the detection and prevention of incidents. Then, the creation of an intelligent marketplace for instruction models for production cyber-physical systems, fundamental in assembly lines, based on optimization of the smart factory. This marketplace can constitute a real revolution within Industry 4.0. It can make the vision of the integration and interoperability of cyber-physical systems a reality, which could exponentially multiply the productivity of the smart factory, and support the development of intersectoral services to exploit models B2B and B2C business. Additionally, from the technological point of view, one of the leading innovation consists in the application of various technologies, highlighting IoT technologies and semantic technologies to the organization and control of the industry value chain through safety of the life cycle of products and the production system, together with its optimization. Thank you very much for your attention.